Thank you. So, yeah, my name is Claudia Hauff. I'm an assistant professor at Delft University, and this is work actually two of my new PhD students did on the topic together with me, and two of my colleagues, so Georgios and Geert-Jan. And so what we are really interested in is what is called transfer learning. So Delft is running quite a lot of MOOCs. We have more than 20 that we're continuously running, and we're trying to actually build our expertise in experimenting with MOOCs. And I come from a computer science faculty, so we're looking at questions that we can really solve in a data-driven way. Now, first I want to really make the case for learning transfer, because what we have seen so far is that really there's a lot of focus on what happens in the MOOC environment. So I was just in your session where we talk about what type of videos are good or bad, how students can learn and so on. And so we have a lot of data about these kind of MOOC environments, and we use it for all kinds of different purposes, right? So we use it for retention and success rates in general, and also for this general concept of learning. But learning itself is only one part of the whole process. So we are running MOOCs to get students to learn, but we also run these MOOCs so that in the end, the students can actually apply that knowledge. And learning is not the same as applying the knowledge in practice. I can test learning, with my exams, also in the MOOC, but that does not tell me how the students are doing actually in the months, in 6 months, or in a year's time. And this is what's called learning transfer. So to what extent is what I learn, to what extent is that applied in practice? How much of what the students learn in a MOOC do they actually use later on, which tells me as an instructor of a MOOC how much of the knowledge I've conveyed is actually useful to students. And so we're really fascinated by the topic of learning transfer, why you will see in one of the next slides. And we had a number of questions around this. So the first question is, well, to what extent does learning transfer actually take place? There's a lot of literature in the classroom setting and the workplace setting that indeed this thing exists, it happens a lot, and is really important. Right? But we haven't found anything on MOOCs. So we really wanted to make the case that student retention is great, passing exams is great, but actually the one key feature that we have so far been missing is really this learning transfer when students apply the knowledge. The second question, obviously, who is actually doing this transfer? So again, we draw from the literature, and we know that there are a lot of characteristics that have been identified for people that actually are most likely to do this transfer. And lastly, we were also interested in what happens over time, right? What happens 6 months, a year, 2 after this course is finished? Can I still observe transfer? Now, the main challenge, of course, in all of this is data. We have a ton of data from the MOOC, but very little else. So we need data that is longitudinal, that we can observe people over time. We need data that is accessible at scale to us as researchers. We need, well, obviously large data, because everything else is not so interesting from my perspective as a computer scientist. And of course, the data has to be relevant to the case that we have, to the specific MOOC we're interested in. And so the general research that we're trying to set up with these two students is really to go beyond the MOOC environment. How much can I learn about the whole process of learning from the students, what the students are doing, instructing and so on? How much can I learn if I look beyond this environment? And since I come from a web information systems group, for us it's obvious to actually look at the web at large, and specifically at the social web, right? Because we know many, many people are active on it, and we also know that there are many different types of platforms, right? Everybody from you is at least on one of those I mentioned. If not, then you're an outlier. So hundreds of millions of people are active on these social platforms. Most of them are for our private lives, like Twitter and Reddit. But there are also some that are actually for our professional lives. And for this case here, we looked at GitHub, which is one particular platform that has reached millions of people, and it's for programmers. So let me just tell you what GitHub is in case you don't know. So it's the most popular, what's called social coding nowadays, the most popular social coding platform. It's hosting coding projects, you can collaborate, you can contribute, everything you can also do in other social networks. And it has very detailed information which you can get. So it's very friendly to researchers because all the data is openly accessible. Yay, very rare. Now, it's also quite old, so it was established in 2007, which means that for some learners, we actually have data going back to 2007. So we can trace back, in theory, what they did 8 years ago. And we can relate it through their progression of the MOOCs they've taken throughout the years, and whether or not that actually changed what they did on this platform. So long term is also great, and it's large. So exactly what we need. Now here's another screenshot which shows you actually one particular GitHub project. So what is important here is that we have really very detailed logs, so any single character of code you change goes in there. It's available. We know exactly at what point in time you changed what type of code. And yeah, so these code changes themselves you can also download. So not just that you changed some code, but we also know what exactly that code was. And of course, we have all kinds of metadata about the project, how popular, and so on. Now, for this particular presentation, we really focused on how much code somebody added or deleted, nothing else. So we took quite the aggregate view of this. And, well, we came up with a number of hypotheses, and all of these are really based in the literature. Again, not in the MOOC setting, but in the general workplace and classroom learning. So hypothesis one is that only a small fraction of the learners of a MOOC, so the engaged learners that actually start the MOOC, will actually do some sort of transfer. Hypothesis two is also that research has found that if you're intrinsically motivated, you're more likely to transfer. So meaning if for some reason you really want to learn something and it's not required by your job or any external factors, then you're more likely to succeed and actually apply that knowledge. Now, if you believe you can succeed, you succeed. So if you have high self-efficacy, then you're more likely to transfer, which I guess makes sense. And we also looked at other established research that looks at how people learn. So if you're a high-spaced learner, so if you learn over time instead of cramming for learning sessions, then you're also supposed to be more likely to transfer. And lastly, that's again from the literature, so transfer decreases over time. So we had these 5 hypotheses, which have been known to hold for the classroom setting, and we just had the question, so what happens now? What happens in the MOOC setting? So how did we go about to actually look at these hypotheses? We took one specific MOOC, which runs in Delft, which is called FP101, and it's a function programming MOOC. We looked at the data we get from it, so all the usual edX logs. We looked at survey data we sent to the students, and we also looked at the students' coding activities. And GitHub is very friendly in that you can very simply actually link edX to GitHub just through email addresses. So we didn't have to do any magic linking of accounts. We could just simply query for email addresses on GitHub. So it's a great resource if you're a computer science researcher. Now for edX, we had the 3 months of the course. But for GitHub, we actually got 3 months of 3 years of data. So 2.5 years before the course started, the MOOC, and half a year after, just because that was very feasible to do in a short amount of time. And what we looked at in these GitHub logs is really what changes are you making in a function language, because FP101 is a function language. And actually, it's an introduction to functional programming. The course language is Haskell, which is a very strange language, but preferred by the instructor. And it's a typical XMOOC. So it's just a bunch of videos, and you have a lot of multiple choice questions that you have to get right to pass the course. There's not much else going on interactive in this course. Now, we had about nearly 40,000 people actually wanted to take the course. As usual, engagement initially was, well, high, and then it sharply dropped off. So we had 41% of the students who were actually watching at least one video. The completion rate was then 5%. And most interesting, of these 37,000 people, we found a third on GitHub. So we could not match all these learners, which makes sense. Not everybody might have a GitHub account. But actually, a substantial number of those were on GitHub, so we could actually work with those people. And the 1.1 million number here is just the number of GitHub events we could get from GitHub for these people. So similar to edX, GitHub logs everything. And in total, we had more than 1 million events we could look at. Now, the first sanity check we actually ran is to look at if GitHub data is representative for our course, if what people do on GitHub relates to what they're doing in terms of learning, then we should see a spike in Haskell programming when the course is running. And luckily this turned out to be true. So this is exactly the 3 months of the course. And as you can see, Haskell programming is going strong, only for that time. So this is actually the number of lines that people have added in the Haskell language on GitHub at that time. And this is only the people that are actually in our course. Now, as you see here, we have the data before the course, during the course, and then after. And we actually threw out all the data from during the course because, well, that's the one that is most biased, so we did not take care of that. And so the next step then was to look at different types of partitions of learners. And the most obvious partition to us was, well, what is the difference between the people we could find on GitHub, which we called GitHub learners, and those we could not find on GitHub, which we assume are more, well, maybe less experienced programmers, right? At least we did not see them there, so it's likely that they're not, maybe new to programming even. And as you can see here, we looked at a bunch of statistics. Well, actually, we looked at many more, but here are the main ones. The last 3 are actually statistically significant different. So people who had a GitHub account, presumably were programmers, watched more videos, they tried to answer more questions, and they got more correct, which makes sense. So GitHub learners are more engaged, and they have higher levels of expertise. Again, something you would expect, but it's nice to get this actually confirmed. Now, in the next step, we went well, one step further, and we actually only looked at these learners from GitHub. And we divided them into 2 groups. One group where all the learners, where we knew these people had programmed functionally before the course started, which we call the expert learners. And then we had this other group, which were all the people who had never programmed functionally before the course. So these are our novice learners. And again, we run the same statistics. And as you can see, the one who already knew how to program functionally were actually the most engaged, which I found horrible, but it kind of makes sense, right? The people who know how this works, they're more likely to succeed in the course. So the expert learners, again, they were more engaged, and they, of course, had higher levels of knowledge. Now, that was, well, it was nice to have this view from the data, so it confirmed that GitHub is a good source. But it was only very basic information. And we really wanted to know is, remember the transfer learning question has to come back somehow. What happens? How is transfer taking place? Is it taking place? And the first thing we looked at, well, does the course impact expert learners? Now, for expert learners, it's hard to figure out whether or not they learned something new from the course because they already could program functionally before. So we looked at, do they program more functionally after the course? And actually, that's not the case. So what you see here is, well, a typical graph that I should have done better. This is the 3 months of the course. This is a time period before, 2.5 years. And this has 6 months after the course. And this is a bit of an outlier because we didn't have the full month of data. So as you can see, it's pretty much linear increase, which would have happened without the course as well. So for expert learners, those that could program functionally before, we actually cannot say much. So the amount of functional coding does not really change. So what we're currently doing is we're actually looking at how they code functionally, which is a much harder question, and we require much more expertise for that. But at least the amount of coding did not change. Now, most interesting to us are, of course, these novice learners, the people that never programmed functionally before, took the course, and what happens afterwards? Now, as you can see here, actually lots happens. So this is the course where they start programming functionally, which is great. And then over here, we see that around 40%, 35 to 40% of all their coding activities afterwards happen in a functional language. So learning transfer occurs. Now, this graph looks nice, but I actually only looked at those that started functionally program afterwards at all, which is 8.5% of the learners we had. So for 8.5% of people who took the course, engaged with it, and actually tried to pass it, we actually found that they transferred, which is a very low rate. So in total, we had about 300 students out of the 37 that registered, where we could observe transfer. And for 300 students, this is something I can also get in a classroom setting, right? So that was a bit disappointing and quite an eye-opener, actually. Now, interesting, and this is in contrast to the literature, learning transfer does not decrease over time. So even 6 months after the course, still about 35 to 40% of all the programming that these people did, the novice learners, was functional. So after this initial hump, it didn't increase, but it also didn't decrease. And then we also asked the learners, because we were really kind of, we couldn't really explain why this is not higher, right? A functional program is supposed to be great. If you're a computer scientist, this is a new hype. Everybody has to learn functional programming. But actually what turned out to be the problem is for most people that were already older, so 25 plus, they simply said, well, I can never apply it. In my company, nobody does it. So even if I want to program functionally, since nobody else does it around me, I cannot actually force it on anybody. So I just stopped because I'm not allowed to use it. So this lack of opportunity was, I think 80% of people that we asked said this was the main reason why they could not apply what they had learned. Now, and to also get back to the rest of the hypothesis we had is that, again, we did this through questionnaire data. So we found that learners who are intrinsically motivated are more likely to transfer, makes sense. Learners who have this high self-efficacy are more likely to transfer. And also, if you're already an experienced programmer, you're also more likely to transfer. Again, so this confirmed what the literature said. So most of the time, it actually works out. Now, one very interesting finding at the end is when we talked to our software engineering colleagues, they were really curious about what do learners do. So as I said, Haskell was a course language, which is a really obscure language nobody that I know likes. So what do students do with Haskell over time, right? And this is all our novice programmers. And this is the start of the course. And this is until June this year, or July this year. And as you can see, initially they actually do program functionally in Haskell, this language, but the main language that's important for industry nowadays is Scala, so this is a great one. And they quickly move, right? So they might learn a little bit from what you tell them, but eventually industry wins out. And what is important for industry is the language they turn to after having learned these initial functional concepts. So this was the course. Okay, so what are the main points we take away from this? Well, most of the transfer learning findings from the classroom literature hold. The major difference is actually this transfer learning rate. So in the classroom setting, we found papers saying 60% of people transfer, which is an immense amount of people. We just found 8.5%, so very low. And this is really already a nice number because we took out all these people that were not really engaged with the course or stopped very early on. So this is, I cannot say differently, it is very low and quite disappointing. And we also found that no matter what you teach, in the end, at least in computer science, industry wins out and people move to what is required from a job and not so much what maybe you as a scientist want to teach them. So what we're currently doing is to go a bit further with this is we look beyond just counting the number of lines of code, but we really look at what concepts of the course have been applied by the students. So if I know all the source code you've ever published, I can actually pinpoint, okay, what part of the course was valid to you, right? How many lectures do actually students apply this knowledge from in practice? Which hopefully is interesting to the instructors because it tells them maybe what to change or at least what to think about, to put it carefully. And that's it. Thank you very much.
Do I need a microphone? Okay. So I'm a little unsure about your definition as well as your measurement of transfer. To me, if somebody learns the course in one language and is able to code more effectively or is able to apply the knowledge to another language, to me that is pretty standard transfer or typical transfer. And I had the impression that your measurement was based on how many people programmed Haskell before, programmed in this Haskell language before the course and after the course.
So what we did is we took all the functional languages and we aggregated them.
Okay.
And then at the end we looked at, so if you look at this graph, that tells you all the languages we actually looked at. So Haskell, Scheme, Scala, and so on. These are the main functional languages, and basically this graph we aggregated before. All the results you saw before was for all functional languages.
The little bar plots?
For all functional languages.
Okay.
This is the only time where we actually look at this specific language that students use.
And could you explain again, how do you get the 8.5%?
Yeah, so these, we looked at all the learners who did not program any functional part before the course, and then we just thought, we looked at how many of those started afterwards.
Right.
And then we took out all of that actually never engaged with the course. So in the end, we really only looked at people, okay, how many people, I think, watch at least 20% of the videos. If I take this number and I know these have never programmed functionally before, how many of those start afterwards? 8.5%.
So you are confining two factors. One is the ability to transfer. The other is having the opportunity to transfer, right? So these, the rest, you know, how many, 52% might gained the ability to be able to transfer to the knowledge they learned. They just didn't have an opportunity.
Well, actually, so the learning literature tells you that if you don't transfer after a few months, that knowledge is pretty much lost again, right? So this was 6 months after the course. And if you haven't started 6 months after the course to program functionally, it's very unlikely that suddenly you'll get the inspiration to do so. So we actually drew from the literature to decide that 6 months is a good time. If you haven't started by then, it will never happen. And functional programming in particular is something difficult. So if you don't apply it, I think it takes like a month or two, and your knowledge is mostly gone, unfortunately. So in a way, it was good because it was a hard course where you can really very easily see based on log data whether or not people have picked up concepts, which I think is much harder if you teach something like history of wars or something, because we cannot really observe this, right? We don't have data for that. But for this, I think for programming courses, this kind of methodology is actually great because it can tell me as an instructor pretty perfectly what people do with the material I teach, whether or not they actually use any of this in practice.
Thank you.
Time for one? Okay. Following up on that, if you had used a different language like Scala, which you said was much more popular, do you think the results might have been more different?
So actually we are in contact with the people that run the Scala MOOC, and we are running all these experiments now on the Scala MOOC. Yes, the results will be a bit higher because Scala is much more industrially relevant. But actually they're not that much higher. So transfer is there, but this is a hard course. So I think most of the people who take this course have already a bachelor, and most of the bachelor students drop out. So it's really one of the harder courses you can do as a MOOC, I think. Thank you.
Hi, I'm Yoav Bergner from Educational Testing Service. Some of you know us as ETS. My presentation for you today is sort of a two-pronged attack, so I want to ask you a question, which is how many of the people in the room are actively involved in developing instruction or instruction technology for MOOCs? Sort of show of hands. Okay. And how many of you would say that you are actively involved in assessment? Okay, actually a lot of you. So then, great. Then I'll sort of equally weight the two prongs of the two-pronged attack. So the motivation starts from this idea of small group discussions, which anybody who's ever taught in anything other than a large lecture hall knows is useful. It's a well-established, highly valued practice. Of course, if you're teaching fully online, then you must replace that face-to-face small group discussion with some sort of computer-mediated discussion. And most learning management systems have asynchronous opportunities for this, but not very many of them incorporate real time. So there are some external tools for doing this within the current world, within the current set of MOOC platforms. Bazaar is something that was mentioned earlier today and is a really impressive tool developed by Carolyn Rose and collaborators at Carnegie Mellon. MOOC Chat, which was developed by some Berkeley researchers. Both of these have been incorporated in MOOCs on edX, but they basically, they wrap up the development of the assessment task and the collaborative affordance in this special authoring environment that is sort of hosted on a remote server and then kind of connected to from the MOOC. You can certainly use Skype and Google Hangouts if you want your students to engage in discussions, but then they're completely outside of your ecosystem, and you don't really know, you don't have no logging abilities for what they're doing. So we wanted to be able to have the small group discussions take place as part of the MOOC ecosystem in a more seamless way. And the last bullet point is that whatever this small group discussion affordance is, it can be used not just for teaching and learning, but also in the context of thinking about assessing collaboration and collaborative problem solving. So that's the project that we wanted to do, which is to deploy an experimental platform for collaborative assessment. And let me describe what that is because it's not intuitive. So if you give a math test to your students and they talk to the person next to them, that's usually called cheating. What we wanted to do, though, is consider the possibility that giving students a chance to take a math test with a partner is interesting in and of itself. And it may not be sufficient for anyone who wants a good handle on how much mastery of math an individual student has. But it's a great supplement if you have an individual measurement to take a collaborative measurement, because then it's a new context that gives you the chance to see what you can do in this kind of, if you're a Vygotskian, in the context of possibly working with somebody in your zone of proximal development who enhances your ability to perform. And of course, in the real world, you will perform collaboratively. So collaborative assessment can mean many different things. We wanted to boil it down to something very basic, which is give students a math test individually and give them an equivalent math test to work on with a partner, and observe what effect size that collaboration has on their performance, if any. And if there is an effect size, then try to understand why there are larger effects, what makes somebody a good collaborator or bring out that sort of knowledge sharing with their partner. So we wanted to do that online. We wanted to explore some statistical models for it. We were going to do the pilot studies using crowd workers on Mechanical Turk, which turns out to be not the best way to get good data. And we were going to do it in math. And this project is a collaboration principally with Peter Halpin at NYU. As a sort of corollary of doing this, we wanted to develop the technology for doing this, and we decided to do it within the OpenEdX ecosystem by developing an extension for it to enable small group real-time chat on assignments. Now, I'm going to take a slide to say why would Educational Testing Service use an open source MOOC platform to do research. So the first thing is that we have an interest in studying collaboration and collaborative assessment. The group that I work in is called the Center for Advanced Psychometrics, but there's also a Center for Academic Workforce Readiness and Success, which actually funded this particular project. And there are some proprietary developments for work that might lead to products that ETS could use to assess collaboration. But at the same time, there's sort of an educational mission that ETS as a nonprofit has, which is to sort of improve the quality of educational services. And contributing a tool to the open source community meshes nicely with that mission. OpenEdX already had a lot of tools that we could use if we wanted to get creative, although we didn't get creative with the assessment items in this particular pilot study. So from a more technical technology level, the CPSX stack, so to speak, is that you have OpenEdX running, that you have an XBlock that's written in Python, and that you have a chat application, which, you know, for our purposes is written from scratch. It's Ajax PHP. It doesn't require OpenEdX, but it talks to the same SQL server. So if you are running some sort of canned OpenEdX instance, you might have to add some of these Apache PHP servers. The design consideration, which was important for why we created something new rather than using Bazaar or MOOC chat, as I mentioned, is we wanted, first of all, to be able to limit chats to small groups. We wanted to be able to use it with any media or assessment items, not specifically authored for this. So if you already have items you like, you could just use them, and now you can add small group discussions. And we didn't want you to have to maintain a separate server to do it. So rather than a demo, this is sort of a walkthrough of what it would look like. But I do have an instance running, and if you're interested and come talk to me, I can sort of set up a credential for you as an author so you can actually create a demo course and use it. But if you've ever looked at OpenEdX at all, at some point you're creating an instructional unit, and you would have everything except for maybe this advanced button, which you have to sort of enable in a setting when you have extensions to edX. And when you select that advanced component, if you have CPSX installed, you'll see this collaborative problem-solving choice. The only thing you really need to do as a configuration choice is you need to assign a name. And the purpose of assigning the name is this is a common identifier of this chat session across screens that you might take students to. So they can navigate through different screens, but they'll be in this session. Because there's a unique session, I can actually be collaborating with 2 different partners on 2 different projects at the same time. And the others are sort of self-explanatory. There's a group size. And there's a wait time, which has to do with queuing people so that they start the assignment at the same time. If they didn't come into the page at exactly the same time, you might need to synchronize them. So then the student experience is that they'll see this problem, which in this case is a numerical response to a word problem, and underneath it will be the chat. And normally this initiation stage would take place before they start the assignment, but for continuity of the presentation, this unit is literally inserted below the problem unit when you're an author. So now it would appear, and when they've clicked on it, they see this kind of countdown while they're waiting for a partner. Then that becomes a begin button. And then once they're sort of begin, now they have this sort of chat session. And that will follow them everywhere that you've duplicated this unit as a course author. This will follow them around. And we have an explicit logout condition. The reason for that is if they accidentally get kicked off of the system because of a network loss, we wanted them to be able to come back into the same session they were in before. And this, you could actually use this to then have a collaboration go on for days and days and weeks, because as long as they don't log out, that chat session will always be loaded onto their screen. Okay, so now for the experiment side of things, I mentioned this a little bit. We wanted to conduct an experiment, and we were going to use OpenEdX as a delivery and a scoring mechanism. The item pool, which if you know anything about assessment, you know it's expensive and difficult to create high-quality items. So we repurposed, publicly released NAEP grade 12 level math items and calibrated them on our MTurk population sample by just giving them as individual tests, kind of matrix sampled from our item pool, and used an IRT model. If that means anything to you, we used a 2-parameter logistic model to calibrate the items, so we got a difficulty and a discrimination for each one of them. And then during the experiment itself, the idea was that you would come in and you would do a math test form by yourself, which was taken from that same calibrated pool. And then you would go into the second form, which you would do with a partner. And you would have this chat throughout. So you'd answer about 26 questions in the individual portion and 27 questions in the collaborative portion. And it was deliberately a bit harder by design so that there would be less of a ceiling effect if the collaboration did improve performance. So I mentioned here that ultimately you would like to kind of counterbalance this for fatigue and practice effects. In the pilot study, we didn't do that. But we recorded the interactions, and this shows you our sample sizes. We were trying to get 50 or 60 pairs. We got 46 usable pairs, which was pretty good. So I'll show you some results, and they're preliminary, and they're not amazing. But the first result here is a plot of, so in an IRT model, or if you're not familiar with it, your score is translated into a latent trait, which is sort of your math ability, and we call it theta. So it should have a fairly functional monotonic relationship to the actual proportion of items correct. So on the horizontal axis is this measurement of an individual ability, and on the vertical axis is the measurement of ability from the collaborative test. Now, if both partners in a collaborative test gave all the same answers, then they should have the same collaboration ability, though they had different individual values. And the colors and the lines connecting the points show you the pairs. So in this early data set, you can see pretty good evidence of non-collaboration because they basically are not giving the same answers, and so they're kind of aligning to where we would have expected them to be along the line within some noise. So the problem with this condition is that in a mechanical Turk experiment, you tell people you're supposed to collaborate, but they just don't because they're there to get paid. So we gave them new instructions that said you're not going to get paid unless you and your partner give the same answer. And then that happened, which was a lot better. So there's still some variations in there, and that could be because somebody dropped out in the middle of the task. It could be because somebody omitted answers rather than putting them in by mistake, or in some cases, one of the partners was moving ahead so fast that even though they were trying, they couldn't keep up. So among this set and the earlier set, I want to focus on, I want to focus on this group. And the filter here, as it says, is that both partners' proficiencies are 0.35 points in the sort of standardized unit system above what they did on the individual test. The reason for that is that that's about the size of the standard error of measurement on that ability. This is maybe generous for labeling something as a positive collaboration rather than wanting the points to be even farther off of the axis. But as you can see, we don't have points that are very far off the axis. So we're going to be generous and inclusive and say that these pairs are evidence of positive collaboration. And again, notice that one of them is they didn't give the same answers, that diagonal pink line. But for the most part, the others gave the same answers. So the question is, among these pairs, which represent 10 out of the 46 pairs, what is it that makes them successful in collaborating? And collaborating could really be just sharing information effectively. Like there are some things I know and some things you know, and together we know more. So this is very preliminary, but when we inspect it, this is what it looks like. It looks like it's not the number of chats. If you just count the number of chats, then the sort of white bars are the distribution of all 46 pairs, and the green bars represent the ones that were positive collaborators, and that fits pretty consistently with the same distribution, so it doesn't seem worth exploring whether there's any differences there. You could look at the balance, too, just to see maybe if one person is really dominating, they type a lot of things, the other one doesn't, and that could be good or bad. But that doesn't really seem to be different in this population either. So it's not the sum of the chats or the difference in the number of chats, so maybe it's somewhere in the actual words that they use. What did they say? And we have the chat logs. And in this pair, you can see that sometimes they're doing things that would constitute evidence of collaboration, but not always. So in the beginning, if you're reading ahead, there's sort of a discussion about, are they asking for the dollar amount or the percentage? I'm not sure, me either. I think it's the dollar figure, okay. So they've actually resolved an ambiguity that most students would have that could lead them to a wrong answer, and because they resolved it, they got it right. But in the next problem, which is the last one, they just say, I don't think the graph has the information, so I'm just going to guess that it's 1%. Okay, me too. So, that's not enforcing particularly good behaviors, and at the end you can see that they're like, get that money, and that's visible in a lot of the chat logs. So to end on sort of some light post hoc analyses, you saw some sort of positive affect in here. If you built the simplest classifier you could, this would be the best classifier ever, lol. Literally, lol. So here's a decision tree to decide whether they're going to be in that positive group based on frequency of word counts. If they used lol at least 7 times, then 4 of those out of those 7 groups actually were in that high collaboration group. So that's a good classifier, apparently. If you want to get a little bit better than that, keep calm and mention the word number. So now notice that you had to use lol 8 times, but that's a very selective group. 4 of those people, 4 of those pairs were in the positive collaboration group and only 1 false positive. If you didn't use lol at least 8 times though, but you did use the word number twice, and you didn't say don't too many times, then 5 positives and 4. So yeah, I mean, I'm not taking this very seriously, but I just thought it would be fun to show somewhere what we're trying to do now that we're mining this a little bit more. More ongoing work with this is actually, we have a statistical model. And if you're not sort of a statistical model person, I won't spend a lot of time on this equation. But basically what this represents is a certain family of interdependence models between my ability to get my expectation that I have the ability to get a problem right, and yours, conditional on sort of our math ability. And then, sort of what it would look like if we acted independently, but were scored together. versus if we really kind of contributed additively, or if one of us dominated the other. So this sort of dominance and additivity is incorporated in this model by these weight parameters, W. And so we can actually rule in or out certain interdependence models in our data set. We're parsing the logs. And in doing so, we can see that the Amazon Mechanical Turk data are not particularly strong. The workers are not that conscientious, and they're not really our target population anyway, which is a student population. So we'd like to conduct a small study with NYU undergraduates, and then hopefully, secure some funding to scale that up. And then we'd like to improve the XBlock. So if that's something that you're interested in, and here are some of the ways in which we would improve it. So right now, it pairs you essentially random conditional on availability on a first come, first served basis. But you would like to be able to say, well, we're searching for a certain homogeneity or heterogeneity of the people in our pairs, so we want to condition on other aspects that we have in that student's database. We might want to stop a student from going ahead through a sequence of everybody else, and right now we don't control that synchronization. They have to negotiate that they move together at the same time. We might, if you wanted to allow a range of group sizes rather than wait until you have exactly 4, you might say, okay, well, if nobody shows up, then allow 2 or 3. And then we have some sort of lighter, well, not lighter, but sort of orthogonal directions. It could look better in terms of color. It could, if you have a strong AI that you want to give to this project, you could provide intelligent support for that collaboration. And that's something that Bazaar does that we don't have. And issues about how this performance will scale up is something that we don't really know. So that's something that an expert on those kinds of things could help with. So all of it is now on GitHub. And that's really my conclusion. I sort of left the wish list up there, and I wanted to thank sort of my NYU collaborators and ETS collaborators, and thank you for listening. Yeah.
How do you see this model working maybe in open-ended questions?
What do you mean working? Say more.
Do you think that this kind of model would be supportive or would help students with open-ended questions versus just the forced choice?
Do you mean the statistical interdependence model, or you mean this sort of framework for small group discussion?
The framework.
Oh, well, I mean, the framework, the idea behind the tool is just to have a seamless affordance as part of kind of the OpenEdX experience for the author to just say, I would like the group to be able to have a discussion without having to leave the system, and I want to kind of record that for analysis possibly later. So absolutely, I think you can use it with anything, in any subject, open-ended, or otherwise. It just gives them a chance to not have to leave the system. Yeah. So the nature of these problems, the reason that they're sort of numerical responses to math questions is that as psychometricians, we have a pretty strong handle on the model for the relationship between ability and correctness. But even if you're not interested on that aspect of the model between ability and correctness, you just want that affordance, then absolutely you should use it. Yes, Chris. Charles. My bad.
I'm just wondering if you were thinking about other traits that might affect this. So, I mean,
Yes.
everyone's had that experience where you're in a group and you're growing.
Yes. Yes. Thank you for asking that. Yes, we are thinking about that. So essentially, you may not like working with other people, and that could be a personality, a temperament variable. So ultimately, yes, we do want to include that as a survey. For the purpose of this pilot study, again, it's so challenging to get a crowd worker population to play along that it was tough to even ask them something like a 10-item personality inventory to see something about a sort of correlationship between extroversion and a positive effect of collaboration. But 100%, yes, we are thinking about other traits. Well, I just want to remind you to find me if you want to demo this and see if it's something that you could use. There are instructions on how to install it on the GitHub, but it's not completely trivial, so I'm happy to provide assistance in any way I can. Thank you.
Okay. As we're approaching our party and things like that, my name is Myk Garn, and I'm with the University System of Georgia. I'm the Assistant Vice Chancellor for the New Learning Models. So one of my projects this past year is to lead a task force that looked at what kind of strategic thinking do we need to do, and how do we go about doing it for improving and transforming our learning models across the system. And I used MOOCs to do that. So I'm going to kind of talk to you about it and how that process went. New learning models, as we've kind of defined them in Georgia, is that kind of part where teaching and learning get catalyzed by technology. And that's kind of my job. I was asked to come in and do the thinking at the system level, kind of an e-learning strategist, if you will. And my varied career of different alignments is down there on the bottom. Everything from community colleges and corporations to internet startups and systems. So a lot of fun different projects and things. This is kind of my personal ontology of what I think technology is going to do. If you're in this room, you probably believe something similar to that. I think it's more interesting that it came from more of a corporate Ernst & Young in consulting than an educational perspective, but still useful and something to work with. The way I describe my job, in Georgia, we've got a lot of people who are really good at what we're doing now. In terms of online learning and in terms of, I would say also with MOOCs. We have some great folks at Georgia Tech who are doing some really incredible things, and Kennesaw State. We also have a lot of people who are pretty good at knowing what to do next. And about 3 years ago, the system asked our group of distance education folks what we should do next. And they came back with a list of 10 really good things, like we need more bandwidth, more professional development, the typical list you would expect. It's what we needed to do next. But it wasn't very useful for helping the system think about what's coming. How do we really prepare for something different, something in the future? So my job is really to think about what comes after next. Those kind of areas. And this was the kind of process that I said that we needed to look for the future. One of the real challenges, I think, is as an instructional area, someone comes in and says, hey, we are going to double your bandwidth. What could you do with it? It's kind of like predicting what we can do with smartphones before the iPhone was introduced. It's just really tough. It's very hard. One of the processes I think work best at that is scenario-based planning, because it doesn't try and predict what's going to happen. It just uses what's going on now to help you think about what might go on in the future. About 2 years ago, we had a symposium, and MOOCs were so hot. They were going to change the world. So we called it MOOCs and Beyond. It was Georgia Tech. We had great people, and our chancellor came in. And he said, that beyond thing is important because we don't know what beyond means at this point. And we said, well, that's a great idea. We're Georgians. We're going to invent the beyond. So that's what we decided we would do. We put together a New Learning Models 2030 task force. Had about 65 members on it, and they came from various different positions across our 30 institutions. That's everything from our access colleges, which would be two-year colleges in Georgia, to our R1, University of Georgia, Georgia Tech, Georgia State, our research universities. And those were people, everything from provosts to presidents to CIOs. We had student council or student government representatives, faculty council, faculty senate representatives, and a broad range of people from budget areas across the institution. 65 people was a lot, but we really wanted to get a broad cross-section of people working on this. One of the first challenges was, how do you communicate with 65 people? Especially when you've got presidents, provosts, and folks that can't come to Atlanta, for 10 monthly meetings and things. So we decided, well, this needed to be an online kind of thing. After all, it was new learning models. I'm all about technology. I was a chief academic officer and then a director for a virtual university. The real challenge is, of course, we know that people hate doing those kind of things. When you try and move a group into a LMS and say, let's all just communicate and have a great time, they go, dead silent. So there were a few things we knew we'd have to work on, but we wanted to use those new learning models. In addition, and because they were hot, and we thought, you know what? Why don't we do a MOOC? That'd be cool. Get them some experience in what a MOOC would be like, and we'll invite a lot more people to come into it. And I think this is a different use of a MOOC, but this is what I wanted to talk about because it's a way where we were able to change kind of the dynamics of our exploration and our discussion and the people that we could involve in this. So, in addition to our 65 people, which you can see the distribution of the types of folks over there. And so really underrepresented were students and faculty. The faculty includes people who might have been at the system level or at the administration, but also had a faculty appointment. So they considered themselves faculty. But in fact, they were underrepresented, and we know that's a critical element. By going to a MOOC, we were able to have 500 people participate, in fact, a little more than that. And we had a much better distribution of people who were participating in our discussions. Because we're public, we're also folks from nonprofit institutions and also for-profit and some vendors. I mean, we just said anybody who wants to participate in this and talk about what learning is going to be like in 2030, this is the opportunity. So it worked out quite well. We asked the task force 2 different questions. What factors were going to be critical to the success of key stakeholder groups? That's students, faculty, and institutions. We could have picked more, but that was enough to keep us real busy. And what practices, business models would best guide the system and its institutions for the next 15 years. So, to give you an idea how this went, we had the symposium 2 years ago. We created the task force. We did a MOOC called Invent the Beyond, where we built the scenarios we were going to work with. That took fall of 2014. Then in spring of 2015, we had a second MOOC, which was called Explore the Beyond. And we took the 4 scenarios and developed the critical success factors. Then, over the last couple of months, we developed recommendations for the system of what we should do. We just had last week, oh my God, I was so glad, the final New Learning Model Symposium where their recommendations were released. And we now have a website, Twitter, and things like that where we'll be continuing to work with that and the discussions. I won't go into a lot of the details on that. I do want to tell you a little bit about this, though. The change drivers, these are the 5 that we worked with. Shouldn't be anything surprising there. We developed 71 different statements off of that. We asked our people, and what we used in the MOOC were a lot of surveys. Turns out surveys are a good way, an easy way for people to respond. And I, at some points, had to beat people up as virtually as possible to get them to respond. But we ended up having a core of about 45 to 55 responses each time we went through these. So, and it was a varied group of responders, although there was a core of about 20 people that were pretty dependable. Our best, and the guy that was going to get the gold star took a job outside the system just before the awards were announced. So I got to keep the award. That was kind of cool. What we did was take those and come up with 2 characteristics or 2 elements that were the most important, according to our group at the time: the pace of change from slow to fast, and the sources of learning, really open education resources and things, and who controls the sources of learning. When you take those and cross those, you get these 4 quadrants that give you different characteristics for a scenario. So this 1B on my side, to each their own, has rapid change in a closed economy. Then what we did, we both engaged experts. And the neat thing about this, again, using a MOOC format, we went out and interviewed the group of experts on this side and said, hey, read the scenarios, tell us what you think. We were able to use those videos to charge the conversation for our MOOC participants and get their responses. So it worked out well, and it was because we only had to travel video in interviews to our speakers. We got a lot more speakers and perspectives than we would have if we'd invited people in. So little bits of benefits. Then our folks spent a whole day working through these different scenarios, working through, we had 4 of them, thinking about them first. If I was a student in this scenario, what would it be like? What kind of student would I be? What are my factors that are critical to success in this kind of a scenario? The fact that there are 4 of them really helps people kind of get over we tried it once early on just to give them an experience. And if you just get one scenario, it's like, oh, God, it's kind of that frog in the water kind of thing. If you're the frog in the water, temperature keeps going up, seems pretty natural to you that it's bubbling around you. To people who get picked up and put in 2030 and said, hey, the whole world is different, faculty are like this, you just go crazy. And it's very dystopian and depressing. But working through several scenarios, you go, okay, this is, I cannot, and it really got people in the spirit of, but also better experienced at going through this. So just quickly, I'll show you kind of find your own path. This is the environment. This is, you can see at the top, open source, rapid change. This is what we fear the most. I mean, no control, everything's moving at light speed. And for our kind of group, kind of what we think is coming. So these were the things, some of the things that came out as critical success factors and challenges that students, faculty, institutions would face. To each their own. Now this is the closed source, rapid change. So it's still going on, but now institutions are trying to control things. Publishers are a little bit more dominant. These are, proprietary solutions and standards. This becomes a real interesting scenario to think in. This feels a little bit where we are now, that we're trying to keep some control on things, but it isn't quite working right, and things can go sideways. Now this one was fun, open source, slow managed change. This is the one that, it kind of has our, utopian goal of everything's free, but Moore's law has broken and we don't feel quite so challenged with stuff. And there were some interesting things that come out of this, like the rise of librarians and their ability to manage content. It became real interesting. This is the one everyone loved. They said, this is the way the world should be. I'm happy here, and the only thing that worries me is I know it's never going to exist this way. So these were the kind of things in the emotions and the things that people work through. What we came up with, critical success factors, we asked people what's most likely to change. And instruction, that really represents undergraduate, a lower division, upper division, and graduate instruction. Everything is going to transform from the student perspective. Different things that they're going to be looking for and that they're going to need. When we look at new learning models, this is what came out of our group, which is more indicative of what the group would like to see than probably what the group is going to see, and shows us a bit of that disconnect. Blended learning to me is, okay, I know I got to use technology, so I'll say it's blended, but we'll do most of it in the classroom, and I'll use the LMS. And that'll be enough, and no one will give me professional development for a few more years, and then I could retire. That may be cynical, but it represents a group of folks. Enhanced face-to-face, we're even more comfortable with it. I can use the projector and things like that. Competency-based came out very clearly, very early on. So this is a period of time where MOOCs have tailed off. People are trying to go back to what they like, but saw that there was going to be some future. In Georgia 2 years ago, if you'd said competency-based, bad things would have happened to you. So we have now in our system, as part of these discussions, really got people understanding that this is kind of a direction that has some promise and they're interested in, which was part of the process we wanted to go through. Here, critical success factors for faculty. Again, these aren't particularly outrageous or different than you would have expected, but part of this process is taking people through discussions like we need to be more productive, because that came out of the group. We know that. We know we're getting more pressure from legislators to do things differently. What we hear is we need to be more affordable, which means cheaper. And we know our big costs are in our faculty. And So cheaper to us means, do we fire faculty today or do we fire them tomorrow? That kind of stops the conversation. But now when you talk about that in terms of what is a faculty going to look like in 2030, you have a much more interesting place in our faculty representatives, one who is the secretary and leader for AAUP in our state. We wanted to have her involved in this, came out of it last week saying, you know, I have enjoyed this so much. I feel like we've really done something. I want to keep going with it. So that's the kind of discussions and understandings that you can begin to build with this. And because it was representative, because we had something like 2,500 different comments and things that came in through the MOOC, through the survey that we were working with to distill down, and we're able to take back to the task force with a broad range of input, they really felt, and it really was, a very inclusive and open process for people to work through. New business models. Again, just an area that is very much in development, but one that people are just so eager to find ways. So we talked about this some. This is one that I'm not sure we'll go back to the MOOC idea or not, but it has developed some good understandings, and we may need to. But this is one we'll get back into later. Critical success factors for institutions. Standing out from the crowd is, again, this building new relationships with faculty. We had a lot of feedback, a lot of comments that came in that people processed. Some of them were pretty raw and pretty concerned. And it was a great way for people to say those things in an environment that they weren't saying it about our institution today. They were saying it about the system in 15 years. But they were very much today's concerns and worries. So we went through, these were the 4 general areas of the task force recommendations. As I say, those came out last week. Our chancellor was there, our chief academic officer for the system. A number of our representatives talked about the experience and the work that they did. This is now something that's rolling out to campuses. I'll say one of the first next items that we will be doing is that whole focus on competency-based education. And so it's laid the groundwork for that across our institutions to understand that this is the kind of innovation that really has promise for our students, for our faculty, and for our institutions. So those are the kind of things that we used a MOOC for. So a little different perspective that I wanted to bring to kind of the discussions. I know you folks are doing a lot of research into the ways that people interact and work in that. The idea of what we used this for was really kind of the CMOOC environment of connecting a lot of our people together in a way for 8 or 9 months that they work through a pretty, intense and complicated process that stretched their thinking quite a little bit. If you're interested in the work we did, the scenarios are up there. We've got like 36 videos, all sorts of things. The afternext.completegeorgia.org is our Afternext site. And we're also Twittering, so our folks can follow as we're beginning to develop more elements to this and keeping folks in contact. And that's what I did with MOOCs. So thank you very much. And ahead of schedule. Any questions? Okay, well, I have another 5 minutes to talk, so I could just go. No, I understand at the time.
Question.
Yes.
Other than being able to pull a lot more people in, what do you think the MOOC approach to solving these issues was successful? What was it? Like, what was different about that?
Well, some of it was that we got a lot of people who were really motivated to communicate in this, as opposed to a class where you have to be in there. The people who came into this wanted to be in there. And I think all told, our participation from people, almost everybody participated at least once or twice in this. I think that was like 86% or something. So we got a lot of people, and it gave people a chance to really say something they felt strongly about, which is difficult in almost any other environment. And it allowed us to combine it also with smaller group sessions with our task force. And it gave a lot more energy to our task force because they felt these people had given them all of this. So it was really a kind of a symbiotic interrelationship between our task force, which was a core group of people. That's who I beat on heavily when I needed responses, because I could guilt the heck out of them. But it gave them a lot more sense of other people are contributing to this. So it really increased, I think, the social connections that people were feeling in that, and used that to craft something that worked for a lot of different people. All right. Well, thank you very much. I appreciate it. Yep.
Michelle, may I just for a moment? Because of the rain, what we'd like to do is to run everybody back over to where the cafe and the food was. And then what we'll do is escort you from there over to the reception around 5:30. So perhaps now you just go, everybody knows the way to get back over to where the food was.
But there's no food there now.
There may be coffee there. There may be a few cookies left too.